Tax One Tech Academy. I'll be taking you through mathematics. The topic we'll be considering today is trigonometry. So these are the course outline for the course. Types of angles, measurements of angles, trig ratio, Pythagoras theorem, the quadrant, and trig identity. So firstly, we're going through what trigonometry is. Trigonometry is simply the measurement of angles. So we have several types of angles. The first angle we'll be considering is the acute angle. This is any angle that lies between 0 degree and 90 degree. That is, the angle is greater than 0 degree but less than 90 degree. Secondly, we're considering the angle, right angle. It is any angle that is exactly 90 degree. The third angle we're considering is the obtuse angle. It is any angle that lies between 90 degree and 180 degree. Also, reflex angle. It is any angle that lies between 180 degree and 360 degree. The other type of angle includes the complementary angle. It's the angle whose sum is equal to 90 degree. The next aspect we'll be considering is the measurement of angles. Angles are measured in degrees and in radians. So we call one revolution is equal to 360 degrees and one revolution is equal to 2 pi radians. Pi is 180. So 2 times 180 will give you 360 degrees. So 360 degrees is equal to 2 pi radians. So 1 degree will give us 2 pi over 360 degree times 1 degree radian. The degree cancel degree, and this 2 here 180. So 1 degree is equal to pi over 180 radian. For example, what's the equivalent of 73 degree in radian? Solution. You simply put 73 degree times pi over 180 degree radian. The degree will cancel the degree and you have 73 pi over 180 radian. Using calculator, 73 over 180 will give us 0.41 pi radian. You can pause the video and take the following exercise by yourself. What is the equivalent of 90 degree in radian and the equivalent of 180 degree in radian? The answer for 180 degree is pi radian and for 90 degrees pi over 2 radian. The next outline is trig ratio. Trig ratio involves the sine of angle, the tangent of angle, and the cosine of angle. So let's consider a triangle like this. You have your theta, you have your A, your B, and your C. This capital C. Opposite you have the side. These are the angles. Then you have your sides. The sides are the small letter of the small alphabet. This C, this small letter B, and this small letter A. So this side is the opposite. The side that faces the angle directly. This is the hypotenuse, the largest side, and this is the adjacent. So you can also have a triangle like this. This is your A, this is your B, your C, and this is your B. This is your hypotenuse, this is your opposite, the small letter A, and this is your adjacent. So using SOHCAHTOA, your sine theta is equal to opposite over hypotenuse, which is equal to the opposite side is A, small letter A, over the hypotenuse is the larger side, C. Cos theta is equal to adjacent over hypotenuse. The adjacent side is the small b, the hypotenuse is the small c. Tan theta is equal to opposite over adjacent, which is equals to the opposite side is small a, the adjacent side is a b. Using this one, you get exactly the same thing. So no matter the direction you take your angle from, you actually get the same thing. Sin theta here is equal to opposite over hypotenuse, which is equals to the opposite is a, small a over small c, which is same thing as this. Cos theta is equals to adjacent over hypotenuse. The adjacent side is the small b over the hypotenuse is the small c. Tan theta is equal to opposite over adjacent, which is equals to small a over small b. Also, we consider the opposite of sin theta, the opposite of cos theta, and the opposite of tan theta. The opposite of sin theta is cosec theta. We simply take the reciprocal of the sides, which is c over a. The reciprocal of sin theta is c over a. The opposite of cos theta is sec theta, which is the reciprocal of the sides, which will be c over b. The reciprocal of tan theta is cot theta. The reciprocal of the sides, which will be b over a. The next outline is Pythagoras theorem. Pythagoras theorem states that hypotenuse square is equal to opposite square plus adjacent square. So making hypotenuse alone the solid formula, you have hypotenuse is equal to the square root of opposite square plus adjacent square. Assuming you are looking for the side adjacent, from this point you have assuming you looking for side adjacent from hypotenuse square is equal to opposite square plus adjacent square. You make adjacent the solid formula. Adjacent square is equal to hypotenuse square minus opposite square. Making adjacent along the solid formula, you have square root of hypotenuse square minus opposite square. Repeating the same for opposite square, you have opposite square is equal to hypotenuse square minus adjacent square. Making opposite the solid formula, you have opposite is equal to the square root of hypotenuse square minus adjacent square. Let's take a few examples. Example 1. Find the value of sin theta in tan theta is equal to 3 over 5 and theta is an acute angle. Tan theta is equal to 3 over 5. Recall, tan is equal to opposite over adjacent. So here we have our opposite to be 3, our adjacent 5. So what is sin theta? We have two angles. According to Pythagoras theorem, we have 3 angles. So we're going to use the Pythagoras theorem to look for the third angle. Recall, from Pythagoras, hypotenuse square is equal to opposite square plus adjacent square. So hypotenuse is equal to the square root of opposite square plus adjacent square. So from here, our opposite is 3, our adjacent is 5. Hypotenuse will give us 3 square plus 5 square. Hypotenuse is equal to cos. Hypotenuse is equal to square root of 34. So we're looking for what sin theta is. Sin theta is equal to opposite over hypotenuse. Sin theta is equal to the opposite is 3 over the hypotenuse we just got to, which is square root of 34. Looking at rationalizing the solve, you have 3 times square root of 34 over square root of 34 times square root of 34. We have 3 square root of 34. When two solves multiply each other, it gives us a number, which is 34. So sin theta is equals to 3 square root of 34 over 34. Going through the second example, we have cos beta is equals to 3 over 5. And we call cos is equals to adjacent over hypotenuse. So our adjacent is 3, our hypotenuse is 5. So we call from Pythagoras, you have 3 angles, 3 sides. So you have to use the Pythagoras theorem to look for the third side. Hypotenuse is equals to the square root of opposite square plus adjacent square. So from here, we have our hypotenuse. So from here, we have adjacent. Hypotenuse equals to 5. So we call the formula for opposite, looking for the sides of the opposite. Opposite is equals to square root of hypotenuse square minus adjacent square. From here, our hypotenuse is 5 square minus 3 square. Opposite will give us 4 using your calculator. And we are asked to look for the cosec beta. And we call that cosec is the inverse of sine. So from here, you have to look for our sine beta. What's our sine beta? Our sine beta is equals to opposite over hypotenuse. And our hypotenuse is opposite is giving us 4, and our hypotenuse is giving us 5. So cosec beta is inverse of sine, which is the hypotenuse over opposite. And our hypotenuse is just the inverse reciprocal of the sides. That's 4 over 5 over 4.